Question number 12 is a sequence, and they don't tell you whether it's arithmetic or geometric. So the first thing I look at is there a constant difference between terms? Are they going up by the same amount or going down by the same amount? And obviously from, say, 128 to 32 and 32 to 8, the difference between that is not the same, which is telling me this must be geometric. And geometric means that we are either multiplying or dividing by something. And I want to correct myself. You're always going to be multiplying. Even though it looks like there's division going on here, you're multiplying by a fraction, which in essence makes it look like division. And so the first thing we can do is we need to figure out what this common ratio is. And the common ratio, just like a common difference, is take one term and divide it by the one behind it. And so 8 divided by 32, to me that's the easier one to do. It's 1/4. You can write it as the decimal, 0.025. Doesn't matter, but it is going to be a fraction. So now they want you to calculate the exact value of the 9th term of the sequence. And again, I would jump to my formula booklet that tells me that the formula for geometric UN equals the first term times R, which is the common ratio, to the n minus 1. And so for the exact value of the 9th term, and I'll tell you what, I'm going to write this here. Now 9 minus 1, I can go ahead and write that as an 8, and then jump to my calculator and find out what that is, and I'll do that real quick. You can see I used the fraction 1/4, and which is why I put brackets around it before I put the exponent of 8. Otherwise, you would sort of be saying 1 divided by 4 to the 8th power. This may be a case where using the decimal 0.25 could make sure that you don't make that mistake. But they want me, again, the exact value, so no rounding in this case. I'll write out the whole value. And then they ask you to calculate the least number of terms required for the sum of the sequence to be greater than 682.6. So I go to my formula booklet, and you'll know that see that there are two formulas, and one looks like this. I'm going to write them both here for a moment. And the other version is basically the same, except for some reason they've reversed the 1 and the R. And the difference between these two is basically trying to keep the denominator positive. So because I have 0.25, if I say 0.25 minus 1, that will give me a negative answer, versus saying 1 minus 1/4, that will give me a positive. And so basically, that's why I'm going to favor doing that equation. So they want you to calculate the least number of terms required for the sum to be greater than 682. So, oh, sorry, this is not SN or UN. This is the sum. Sorry for that quick little mistake. We're talking about the sum. It is the correct formula. So now I know the sum, 682.6, has to be, when will this be greater than when will the first time that this is greater than the 682? And so now I just have to fill in now. We haven't talked about being able to find an exponent that's a variable. And if you've done some other higher maths, you would know that you could use a logarithm to do it, but basically I'm not worried about that. What I'm just going to do is plug this into my calculator and look on the list to see when will this result be greater than 682.6, and it will be the first time that that happens. So it will take you a moment to type this into your calculator, and you can simplify it if you want a little bit, but you're going to see that I'm not going to simplify it. I'm just going to type it in and let my calculator do the work. The place I'm going to type in this side of the formula is into the y equals, so I can look at the table, and you're going to have to be careful how you type it in. It's 512, and you can actually just type in the brackets 1 minus 0.25 to the power of x, close the bracket, and then that's going to be divided by, now actually I'm going to do that subtraction. 1 minus 0.25, that is 0.75. Let's make my life a little bit easier. So all of that up above gets divided by 0.75 and enter. Now, I'm now ready to go look at the table, and what I'm looking for is when is the first time that this is greater than 682.6. And you can see there's 682.5, 682.63. So the seventh term is when it's greater than 682.6. So my answer is when n equals 7. And there is for part B.